So this is 5-7. We're doing a quiz over 5, 5, 6, and 7 tomorrow. Okay, and then we're going to learn 5-8 on Wednesday, 5-9 on Thursday, and Friday is when we take the NWEA progress check.
What are Jared and I going to do that day?
Catch up on whatever you're missing still in the class or whatever you want to do. For the NWEA progress check, I think I mentioned this, but we're going to set goals based on your highest grade, whether it was in the spring last year or in the fall this year, whichever was highest. As long as you add a point to that, I think if you add 1 point, I'll put in a 90 for a quiz grade. If you add 2 or more, I'll put in 100 for a quiz grade on the quarter.
Seniors, she'll just start.
On seniors, you don't have to do it.
I just think 100
Yeah.
Yeah, if you just want to put 100 in there, that'd be great.
You can take it if you want, and then we'll see.
No, thanks.
Okay. Okay, so it will go in as a quiz grade, and it can really boost your quiz grade average if it's kind of low, if you can show it. And by putting that out there, it's not like I'm going to make you any smarter to see if you can actually gain a point or two, but hopefully it'll make you try your hardest. Sometimes on the NWEA, I think kids go in and don't really give it their all. So hopefully that'll motivate you to do your best, at least, on it. Okay. So section 5-7, we're going to learn about how to multiply and divide complex numbers. And remember, a complex number is just simply a number that's got a real part and an imaginary part. 3 plus 4i, 7 minus 2i. Those are complex numbers. And I, again, is just a radical, but it's the square root of -1. Okay? So when you multiply two complex numbers, the process is exactly the same as we've been doing when we have variables. Okay? You're going to FOIL it. 3 times 4 is 12. 3 times -7i is -21i. 2i times 4 is 8i. And 2i times -7i is -14i squared. Okay, you will never have an answer with an exponent greater than 1 with I. We know what I squared is. What is it? -1. Because I is the square root of -1, and anytime I multiply two numbers with the same radical, it's the radicand, which is just -1. Do I need to explain that again?
No.
Okay, so I squared is -1. So what's -14 times -1?
14.
Positive 14. So that now I've got -2i, or 21i, sorry, plus 8i, plus 14. The I squared's gone.
Can you do that to the others too?
No, because this isn't I squared. It's just I. So I'm going to combine my like terms. Plus, minus, -21 plus 8. Is that right? 13. Okay, so this is the complex number that results from multiplying these two complex numbers together. Okay, you'll always have it in complex form. You'll never have an I squared in your answer. So make sure that when you see I squared, you make it -1, which just basically changes the sign of that number. Okay, so this isn't too bad, multiplying 2. Dividing 2 is a little more complicated. Let's use the same numbers. Well, remember, this is a radical, or root. And we can't have roots in the denominator. Okay, so as a review, if I have a root in the denominator, I have to rationalize it, right? Okay. Let me do this. When I have something like 2 plus the square root of 3, I can't just multiply that by the square root of 3 and get rid of the root. Okay? If I multiply this by the square root of 3, 2 times the square root of 3 is 2 square roots of 3. Square root of 3 times the square root of 3 is 3. I still have a root. Okay? So I can't just multiply it by the square root of 3. I have to use something called a conjugate. This is a vocabulary word, a conjugate. And a conjugate is the exact same terms with the opposite sign between them. How does this eliminate the root for me? Looks to me like it's the factored form of a difference of squares, right? Because I have the exact same terms, but I have different signs between them. With the difference of squares, what drops out? When you have a plus and a minus and you multiply those two factors together, what drops out? I've said it over and over again the last 2 weeks. The middle term. The middle term. Okay. As an example, this is x plus 4, x minus 4, right? If I FOIL this, I get x squared minus 4x plus 4x. Minus 4x plus 4x cancels. There's no x term. Okay? Same concept here. I'm intentionally multiplying by its conjugate, which is the exact same numbers with a different sign, the opposite sign. And by doing that, if I FOIL this, I get 4 minus 2 square roots of 3 plus 2 square roots of 3. It drops out. And what's the square root of 3 times the square root of 3? Okay, so this is minus 3. 4 minus 3 is 1. I've just gotten rid of the radical by multiplying by the conjugate. You follow? But whatever I do to the bottom, I have to do to the top. Okay? So on the bottom I have 1. On the top I have 6 minus 3 square roots of 3 when I multiply. Right?
I don't know where you got those numbers.
What, these numbers?
No, the top numbers.
I made this up. This was my problem to start with.
Right, but I don't know where you got 2 minus square root.
I have to multiply it by the exact same thing I do the bottom.
Oh, okay.
Otherwise it changes the value.
Okay, I see now.
Okay, so it's exactly the same thing I multiply on the bottom, I multiply by the top, because this is 1. 2 minus the square root of 3 divided by 2 minus the square root of 3 is 1. Any number divided by itself is 1. So when I multiply the bottom by the conjugate to get rid of the root, I have to multiply the top by the conjugate, otherwise I change the value of the whole fraction. Okay, when I multiply the top, I get 6 minus 3 square roots of 3, and then the denominator, I already figured that. It's 1, which I don't even need to write now, because anything over 1 is just that number, right? So this is the answer to this rationalized.
Okay. Yeah. So all of that was for the numerator.
Was so I could get rid of the root in the denominator. I can't have a radical in the denominator.
Original problem.
This was my original problem.
But
Forget this right now.
okay.
I'm trying to explain what I'm going to show you with imaginary numbers next by explaining what a conjugate is. Because this is the square root of negative 1. So it's a root. And I can't have a root in the denominator. Okay? So when I rationalize a denominator with a root added to a whole number or a real number, I have to use something called the conjugate. Okay? Same thing works with imaginary numbers. Okay? But instead of calling it the conjugate, we call it the complex conjugate, because it's a complex number. It's got a real part and an imaginary part, which makes it called a complex number. So now I've got to get I out of the denominator because I is a root. Okay? So I'm going to multiply the denominator and the numerator by the complex conjugate. The complex conjugate is the same terms, opposite signs. And I have to do it top and bottom. Okay, so let's look at the bottom first. We should be getting rid of all of our I terms, because if I take 4 times 4, I get 16. 4 times positive 7i is 28i. 4 times negative 7i, negative 28i, my I terms drop out. Now I have negative 7i plus 7i, which is negative 49i squared. What's I squared again?
Take it out. It's just going to be 16 plus 49.
Negative 1. And negative 1 times negative 49 is positive 49. So the numerator is now this. The i's gone, which is my whole goal. I had to get I out of the denominator. My denominator's now this, not my numerator, sorry. With me still? And then, yes. Yes. So in the denominator, I have 65. Okay? In the numerator, though, I have to now FOIL these two, like I did in the beginning. Okay? I know to FOIL, I take the first term times the first term, the first term times the last term, the second term times the first term, and the second term times the second term. Okay, first, what is this? Negative 1. So this actually is negative 14. Right? Now I combine like terms, 12 minus 14, and this is 29. 65. Okay? Now, the final step here, to technically get this whole problem right, you must write it in the complex form, which is the real piece and the imaginary piece. The real piece, right? The imaginary piece, and my I goes next.
So you can't put it together, you have to separate?
Mm-hmm.
This gives me a headache.
You want me to do another example?
I understand that now, I mean, I don't know why I didn't do it the first time. So what you're going to do is you're going to times the top and the bottom by 3 plus 5i.
Good. I have to multiply by the complex conjugate.
So then your i's in the numerator is going to cancel out.
Well, some of them. Let's go ahead and FOIL it.
Denominator, sorry.
Okay, let's just FOIL the top.
Okay. 26 and 10.
So this is 4 or 10. 2 times 5 is 10. I squared.
It's negative 10. Over, but
3 times 3.
9.
Okay, I can go ahead and FOIL it, but I know that the middle term is going to drop out. That's the whole point. So really all I have to do is multiply the last terms. Negative 25i squared is plus 25. I squared is negative 1. So I have negative 25 times I squared is negative 25 times negative 1, which is plus 25. Okay, I'll back up here. Negative 25 I squared. I squared is negative 1. So when I get rid of this, this turns to positive. Okay, and now I've got 12 minus 10 is 2. And on the bottom I have what? 34. And then I have 26 over 34. Simplify. 1 over 17 plus 13 over 17 I.
There you go. That looks easy.
Okay, it's just a few steps, but it's not hard if you understand how to multiply complex numbers. Okay, the last section here is solving equations with complex numbers. This is a quadratic, right? Because I'm going to have an x squared term. in the section before complex numbers, we learned if it's already factored for us, the easiest way to solve is to just get this factored form by itself, right? And then take the square root of both sides, and then get the x by itself. Remember that? I need to do a quick problem there to refresh you. Yeah? Okay, to solve this problem, I take the square root of both sides, right? Then I add 2. So I have x is equal to positive 3 plus 2 or negative 3 plus 2. So those are my two solutions. Remember from, okay. So it's the same process, it's no different, but now we're going to end up with imaginary numbers in our answer. Okay? So I'm going to subtract 16. Take the square root, plus or minus, and what is the square root of negative 16? Plus or minus 4i. Okay? Because the square root of negative 16 is the square root of 16 times the square root of negative 1. This is I, and this is plus or minus 4. Right? So it's plus or minus 4i. So now I've got x plus 8 equals plus or minus 4i. I subtract 8. And I have x equals negative 8 plus or minus 4i. So if I wanted to separate them, it would be negative 8 plus 4i as a complex number and negative 8 minus 4i as a complex number. Those are my two answers. Okay? So process is the same as we did 2 sections ago, but now that you know that you can take the square root of a negative number, just remember to put an I at the end. That's the only difference. Here, we could go ahead and add them together because they were both real. Here, we have to leave them as a real number and an imaginary piece. We can't combine them. Okay, so your answer is just simply negative 8 plus 4i or negative 8 minus 4i. Okay, let's go through the textbook check. The complex conjugate of 3 minus 4i is
3 plus 4.
3 plus 4i. In order to simplify, this is a good one. In order to simplify 8 minus 3i over 6i, what should you multiply the top and bottom?
It should be 6. Negative 6. No.
8 minus 3i over 6i. What if I had 8 minus 3 square roots of 3 over 6 square roots of 3? What would I multiply the bottom by?
8 minus
6.
What would I multiply the bottom by to rationalize this?
square root of 3.
Square root of 3. I don't multiply it by 6 square roots of 3. 6 is real, or is rational, I should say.
Oh, yeah.
Right? I just multiply top and bottom by the square root of 3. Same is true here. I don't have a real number in front of it, so I don't have to worry about a conjugate. The only time you worry about a conjugate is if you have a true complex number, 3 plus 2i, 6 minus 7i. If it's a complex number, you've got to multiply by the conjugate because you're adding a real number to it. There's no real number component. Okay, so all we're going to multiply top and bottom is I. Okay, this becomes 8i negative 3i squared plus 3. And this is 6i squared. So to rewrite it, it would be negative 3 over 6 minus 8 over 6i, because the 6 is negative. Then simplify. Okay, so you don't have to multiply it by 6i. You don't have to multiply it by negative 6i. All you have to multiply it by is I, because there's no reason to do a conjugate. There's not a real part to that number. Okay, so the correct answer here is I. Okay, this would be simplified. This is just breaking it apart into a true complex number where it has a real part and an imaginary part. So we would have 18 over 36 plus 48 over 36i. But then we would simplify that. 18 over 36 is 1/2. 48 over 36, well, is what, 3 or 4/3? So it'd be the second one. Okay, this is partly true. It's broken apart, the third choice here, but it hasn't been simplified. You always have to simplify it. Question 4, I to the 35th power. This is a review from last section. Okay, so let's go through this again. The 4 iterations of I is equal to itself. I squared is equal to -1 because I is the square root of -1. Right? And when I square a radical, it's just the radicand. I cubed then is I squared times I. Does everybody understand why? Why I cubed is I squared times I. Okay? If I have I squared times I, that's really I to the first. You add exponents when you multiply. This is I cubed. So I squared is -1. I is I, so it's -I. I to the 4th is just I squared squared. -1 squared is +1. And then it repeats. I to the 5th is I. I to the 6th is the same as I squared. I to the 7th is the same as I cubed. I to the 8th is the same as I to the 4th. Okay, so if you could figure out how many times 4 goes into your exponent evenly, don't even worry about how many times. Once 4 goes in your exponent evenly, whatever the remainder is the exponent of I.
So 8.
So 4 goes into 32 evenly with a remainder of 3. So it's I cubed. So it's -I. -I. In question 5, when you FOIL 2 complex numbers, at the end there will be an I squared term that then you will convert to -1. Okay? So that is it.